How do we approach problems? Today, your warm-up was to brainstorm what makes a good question in science. I realized I wasn't as specific as I might have been, and a lot of you guys talked about a scientific investigation question, and what we were really looking at today was what makes a good question, say, for a test. So I'm glad you guys were all thinking about doing science, but we do have to look at problems too. All right, we all had great discussions in class. Okay, here's what I think isn't a good question. Clarity. You have to be able to decipher what the goal of the question. So what is it asking you to do? The question has to have enough information to figure out how to approach the problem. It also has to have enough information to solve it if it's one of our math questions, or it has to have enough information so that between that and the knowledge you have, you can write your explanation. And in real life, we don't always have just the information we need to solve a problem. Sometimes we have lots of extra information. And the AP test will sometimes put extra information in there that you don't need. It's there to distract you. So every once in a while, we'll put some extra information in so you can practice sorting through what you have. So how do I solve a problem? Dagnabbit, I guess, right? Okay, let's break that acronym down. All right, D is for diagram. Is there a diagram or a picture given? Would drawing one help? So for some of our problems, I'm going to make you draw a diagram. When we do forces, when we talk about energy, and when we work on circuits, we'll always draw a diagram. When we talk about motion, I'll teach you how to do motion diagrams that will help you interpret a problem. Okay. A is for assumptions. What assumptions am I making to solve this? If the problem says that someone's on an ice rink, one of the assumptions we're going to use is that friction is negligible. We're going to ignore it. And we'll work on finding those keywords that tell us that as we go along. G is for graph. Is there a graph with the problem? Would drawing one help? What kind of graph is it? What does it mean? What's it giving me a relationship for? I is for interpretation. So this is where you figure out what is the question asking me to do. This might work if you're solving something numeric, and this is a more traditional physics problem, but maybe you're explaining something. Or maybe you're selecting your answer from a list and then have to justify why that's the right one. Maybe you're analyzing data. Are you graphing something? This is where you figure out what the goal is. Okay, guess. Most of this applies more to a math problem, but you could probably make this work for a written problem too. Givens. What do I know from the problem? Are there hidden givens? So what a hidden given is something that you know, but they don't explicitly say it in the problem. So when we talk about things dropping, we know that gravity is causing it to accelerate, but they usually won't say that. They'll just say you dropped the ball. Unknowns. What do I need to know? This one's usually the variable you're solving for if it's in math. Equation or equations. This is where you'll take your givens and your unknowns, and you look for the one that has the truth, the whole truth, and nothing but the truth. I want an equation or a pair of equations that have the givens, the unknowns, and nothing else. Okay. Once you have that, I'm a little mean. I make you solve it in variables only. The reason I do this is that I love giving partial credit, and it's a little bit easier to find your mistakes when you make them if you're working in variables. The other reason I do this is that out of your 5 free response questions on the AP test, one of them will have a solution in variables only. So we got to practice it. All right, the second S here is your solution with substitution in units. This is where you'd call it plug and chug. Right? This is your check. I don't want you to redo the whole problem. I just want you to look at the answer for reasonableness. So if I drop a ball from 1 meter high, most of you did this in class on Wednesday. If you get an answer that says it took 10 seconds, you can figure that it's probably not right and go back and look for a particular mistake. You also need to check if you answered the question and if you answered all the parts of the question. Okay, in class we looked at some problems together. If you have them over the weekend, please do not try to solve them. I purposely gave you ones that you don't have the physics tools to solve yet. I just want you to use these steps to look at how you're going to approach problems. When in doubt, 2 rules of thumb. Okay, use this approach. Okay, it's a catchy little phrase, I hope. All right, dagnabbit, I guess. Right? All right. Also, make sure you always read the full question to make sure you got all the parts of it. Okay, your homework consists of the pretest, all right, which is due Tuesday night, and your mastery quizzes. And your exit ticket was to explain the steps of the guessing method. Bonus points if your parents can tell me on Tuesday what it is.